This is ABC and welcome to Data Engineering and Infrastructure Community. Our today's topic is Introduction to Apache Spark, which is
In
presented by
this
Hitesh and moderated
from
by me.
our all this session, we concluded that it will be great that if we focus all our topics considering as a beginner in data engineering, then we move on. So that's why for next few sessions we will move on with the basics levels of like introduction on this thing. Along with the topic of Apache Spark introduction, we will then talk about few more stuff on based on vote, which are like what is happening in Apache Spark, because there is many point of that, do you really need Apache Spark or do you don't need Apache Spark, and then how to write Apache Spark job, and then basic debugging and pain points. These are the four. Another topic after the introduction we will go on. Apache Spark. Apache Spark is actually a data processing engine. It is one of the widely used data processing engine in current ecosystem. And what is so good about it? So the generation started from Hadoop, and Hadoop is an approach which is based on MapReduce. In very simple term, MapReduce is nothing but divide and conquer. So that algorithm which we usually try during interview preparation, that is what the foundation of Hadoop. So the only difference what Hadoop did is it did it on a scalable level, not on a single computer. They did it for multiple computers. So the same paradigm, if you imagine, if you can do it for multiple computers in a server, and then you divide, split the data, do their own data processing, and then merge it, that is what overall in nutshell MapReduce is all about. Then that was the first introduction of scalable ecosystem or data processing for data engineering or any big data project, which you don't need sophisticated servers for that, and commodity laptops can do that as well. And then Apache Spark came up, that was actually enriching everything in memory, and that made everything much better, much faster. So if you really think about the memory dimension or any processing, very basic thing about any processing is none of the thing happens on hard disk. It is very slow. So what happens is whenever you run any process inside a computer, it first create or assign a virtual memory in your RAM. So in the end, you need to go to the memory, and then again it is not fast enough in a RAM as well. So then comes L1, L2, L3 caching. So eventually, if you see, if you can transform or change the paradigm of doing things on hard disk, and you just move every processing on the memory side, then you already can optimize the speed, you can make things much faster. And that is where Apache Spark did brilliantly. So most of the processing happens in Apache Spark is in memory, and then it engineered a very sophisticated solution that when things are in memory and you are running out of memory, it creates checkpointing, it creates many logical approach of saving your metadata in hard disk, read whatever desired based off your memory size, process and move on. So that is where Apache Spark came up, and I think then we can see the foundation of what all the component and things we should be aware in Apache Spark. Then we can throw in general discussion. In discussion, again, I'm saying I will insist of not going on a very high level, but in a low level so that others could understand. And considering everybody is a fresher, then how will we talk? So during the conversation, if you have a question, kindly put that in chat. Then it will be great. And then after the session, we will follow this through. Hitesh, whenever you want, you can take the control and start sharing it.
Yeah. So I'm sharing this. So I think everyone should be able to see my screen now.
Yeah.
Uh, just a second. I'll stop and start again. Just
Take your time in this. That's not a problem.
actually, I was outside and just came back. I was stuck in traffic for almost half an hour.
That's less. Half an hour is too less.
Uh, yeah. Good.
No, as I said, whenever you have a questions, keep on add that in chat, and we will take it over later. Thank you.
So,
And without any further delay, because I think people will keep on joining, I would give the hosting to Hitesh, and he can take over.
yeah.
The thing.
So the basic introduction of Spark, I think Abhishek already explained. So it is almost same thing. So in terms of from their website, so this is the definition from what they've given on their website. So Apache Spark is basically a unified engine for the large scale distributed data processing on premise or in the cloud. So basically, it means since it is a go-to distributed data processing framework, which gives you ability to work with a different sort of data sets, be it streaming or batch, or let's suppose you want to work with different databases or anything. You have connectors for everything. So I'll show you that in detail in separate. Okay. So it was originally developed at AmpLab at UC Berkeley. So they are also, you can also call it, they are like the Xerox Spark of the 21st century. Some facts about it. Okay. So the Spark was basically designed across the 5 key characteristics. So basically, when they were designing Spark, so at that time, what is the key characteristics Spark should have? Uh, uh, Keeping that in mind, the Spark was developed. Okay. So it should have a great speed. Okay. It should be easy to use. It should be modular, and it should be extensible, and it should be fault tolerant. So what do I mean by this? So speed is so basically speed. I don't think I need to explain what is speed. So speed is basically whatever the speed of processing for the scale that they had at that time. So it should be lower. It should have the higher speed or lower processing time from what that they have at the time. So which was basically Hadoop MapReduce in the distributed system, and that was also not adopted at the time at a huge level, because at the time it was also at the nascent stages. Okay. Then the ease of use. So the API should be easily be usable, and it should if someone wants to get into Spark, it should not be really hard to get into Spark, so that its adaptability, it's really simple, just like we had for the SQL or Java, any other popular framework. They are popular because they do that work in they take really low time to set up, and anybody can get started with just few tutorials. Okay. Modularity is again related to that only. So the code you're writing should be reusable and all that stuff. Fault tolerance is like so since we are talking about distributed system, and the main thing is at that time what they were thinking was how to scale. So earlier what used to happen, we used to have the vertical scaling. So at the time the data whatever the databases were there, or whatever the data processing engines were there used to be a vertical scaling, and that hardware used to be really expensive. Okay. And this so when you want to go to a bigger machine, it is expensive. So let's suppose you want to buy a Ryzen 950X, so that costs around $700. Whereas if you want to buy a Intel Core i3. So that is easily available, cheaply available. I'm just giving an example. That is not a good example, I would say, but it is like so. Your normal Core i3 processor has a lower per core processing power, but it has 4 cores, right? And if I have a cluster of 16 i3 processors, and I have one big 5950X, which costs around $2,000, so it will be like difference is really huge. Okay, so my 16 i3 processor will be around something around 12-1300. So we are getting savings of around 80%, and since we are more focused on the parallel processing. So if you have the 10% lower processing power per core, that is not a big issue. So when you have such multiple processors, okay, or computes, so there is a chance of failure as you are increasing number of computes. So there is the chances of something failing is also higher. So a system needs to be developed such a way that it should be fault tolerant. Means it should be resilient to this if any error happens or anything happens. Okay. Now the basic ecosystem of Spark. So basically, in the middle you have the Spark core, and then you have the multiple languages from which you can write on the Spark core. So basically, you have Scala, Java, Python, and R, and then you can on the top of that you have the Spark SQL, Spark streaming, and Spark streaming can be connected with Kafka or other streaming frameworks. Then you have the Spark mlib and Spark graph frames. So these are the different modules of Spark which are there. At the center there is a code. Okay, so whatever you want to do, whatever code you are writing, which it will basically be converted at the end into the Spark code. Okay, so I'll not go deep into this. I'll go what is there. I'll go into deep at a later point. Okay, now you have the Spark framework. So where can you run your Spark framework? Okay, so basically you can run on your laptop. You can have the standalone Spark cluster on EC2 instance or anywhere you want to deploy or on-prem. You can use Yarn. You can use Mesos. You can use Databricks, sort of really famous nowadays. You can use Kubernetes. You can even use the Jupyter notebooks, or you can use the OpenStack. Actually, the Jupyter notebooks are basically a special case for the Spark standalone only. So I would not call it as a separate, but just for the reference, I've kept it. Okay. Now, the Spark is just a processing framework. So it doesn't have any storage layer. Okay. So it depends on the other frameworks or other systems for the storage of data. Okay. So basically, if you are on Yarn or any other varieties of Yarn you get in the cloud like EMR or Dataproc or I don't remember what is the Azure offering. So you will basically have a Yarn cluster on which you will have the Hadoop installed. You will basically have the Hadoop file system there, and you also have the Spark and other Hadoop frameworks installed there, and you can use the Spark. That was the traditional way, or Cloudera or HDP, whatever you are using on-prem. If you are using, then in some cases we use S3. If you're on Amazon Cloud, it is basically go to storage on S3 Cloud on Amazon. Then your local file storage. If you're on Azure, then it can be ADLS, or if you're on the Google Cloud, then you have the Google Cloud storage. Okay. Then apart from this, you will have the different data sources you can connect to from Spark. Okay. So you can connect to a document database like MongoDB, or you can have Elasticsearch, or you can connect to the key value databases like Cassandra or HBase. And if you want to have some sort of graph database, you can connect to Neo4j. You can also connect to the traditional RDBMS, MySQL, Postgres. I've just listed these two, but there are more. Then you can connect to the cloud databases like Cosmos DB or Synapse Analytics. I don't think Synapse Analytics is basically a data warehousing service, but you can connect to it. That's not a big deal. Then you can even connect to the Microsoft SQL Azure or the SQL Server, or whatever you want to call it. You can connect to Snowflake data warehouse. You can connect to Redis, DynamoDB, CouchDB, and Couchbase. Apart from this, so why Spark was famous was basically it can read different files, okay, like text files, CSV file, other files. Okay, so basically Parquet, Avro, JSON, CSV, Excel. There are different packages using which you can basically read the Excel file, but I don't think that is preferred. If you are using Excel, then go for Panda. Then you can even read the images. Uh, you can even read the scientific file formats like the NetCDF. So yeah, so not directly. It's basically you need to use something like X-ray or something like Spark from the NASA. That's where you can use the NetCDF. Then apart from on the top of this, you can you have the open table format like Iceberg, Hoodie, and Delta Lake. So you can connect to those as well. And so these the three Delta Lake, Hoodie, and Iceberg can also act as a streaming source. Since most of the all of the three have the streaming API compatibility as well. So whatever changes that you have, you can get the whenever the change is committed to the Delta Lake or Iceberg or Hoodie, you can get that as a trigger for your Spark. Okay. Now, how basically Spark works? Okay. So, so the first thing is in a Spark. So since it's a distributed processing language, so we'll have the bunch of computers. Okay. On the top of it, for this bunch of computers, there will be a cluster manager, which will be managing this cluster. Then you will have a Spark daemon installed on this cluster. Basically, it will basically act as a Spark master. So whatever job you are submitting, you will basically submit to the Spark master, and the Spark master will communicate with your cluster manager to get the resources. Okay. So let's suppose I have a laptop. Okay, I'm submitting a Spark application to the Spark daemon. The Spark daemon will ask the cluster manager for the resource for the driver program. So what is driver program and this thing I'll come back to that later. So basically, Spark is a works in a master slave manner. Okay, so whatever program you are writing, so it has basically two components. So one is a master, which is basically controlling the complete working of the jobs, and second thing is the workers. So workers are basically they are called executors. So whatever actual work or whatever actual processing has to be done will be done by the executors, and the results will be given to the driver. In some cases, executors can directly write the results in to whatever place they or whatever data sources they want to write it. But in general, it is basically like driver is controlling your executors, and executors are basically doing your work. Okay. So the first thing is, what happened? Hello. Hello. Can you see my screen? Mirror. Okay, just a second. Just a second. Okay. Today I'm using my Ubuntu laptop for the first time for the presentation.
Oh. If it blocks you, just send me the link. I will open it for you. That is fine.
Are you able to see the screen? Yeah. Okay. So basically, the Spark daemon goes to the Spark cluster, and it will ask for the resource. Okay. So basically, when you are doing so while using Spark, you give, okay, so I need this much resource for my driver to run. This many, I want to run this many executors, and I want this many cores and memory available to made available to me for my job to run. Okay, that you give whenever you run your job. Okay, when you are running on your local at that time it is basically taking all whatever resource it can get directly. Okay. So what happens then? The cluster will give Spark master will say, okay, the cluster manager will say, okay, so on this node you have this many resources available, you can start your program there. Okay, basically it says your request is fulfilled. Then what Spark master daemon does is basically starts a driver process. It's so since Spark is basically JVM based thing, so basically it starts a JVM machine first, and we call it as Java. Okay, and if anyone has written code in Java or Scala, so basically your main is your entry point. Actually, in Python as well, your main is the entry point. So basically, it started your main program. Okay. So now your main program is started. Now whatever you have written before creating this, uh, so the entry point to the Spark is basically Spark context, or you can say in your term you can say it's a Spark session. So basically whatever Spark wants to do, whatever driver is, whatever actually master is actually a Spark context, which and Spark context is responsible for everything. So if you want to read something, if you want to write, if you want to read something, then you need to have this. You need to use a Spark context. Then and only then you can read that data, and then you can do whatever you want to do using the given APIs. And then when you are writing. At that time as well. So Spark context has a detail about a lot of things. So like let's suppose you are connecting to the databases. So it contains the Spark contains the details about how to make the connection, what are the credentials, and all those stuff. So that is there. So basically, when I say it is a driver, so driver is basically your Spark session. Spark session is basically your driver. Okay. So as soon as your Spark session is started, whatever code you will have written, so if it has some action, so what is action and transformation, I'll come back to that later at a later point. Okay. So then your Spark session is started at that time. Okay, so what will do, it will ask the Spark master will again ask for the resources to the cluster manager to start the executors. Then it will fulfill the request, and then your executor can be started. So right now your executor has started, but the communication between the master, that means your driver, and your executors is not started yet. Okay. So now what will happen? Your executors will register with the driver. Okay. Okay. So I am available. I am available. I am available. So whatever task you want me to perform, I can perform that task. Okay. And if you see on the executor, I have written slots. Okay. There are two slots in it. So for each executor, the whatever the number of cores it has, it is basically equal to number of slots. The slot, it's not a correct. I think I should have called it as core. So basically, whatever number of cores you have in the executor, that many tasks will be assigned to that executor. Okay, just remember as a thumb of rule. So whatever executor that you have, that many tasks will be assigned to your executor. And what a task, I'll come back to that at a later point. Okay. So now they have started communicating, and the task is assigned to it. Okay. So now once that sorry. So what will happen at this point? Once the task is completed, then the executor will say, okay, so my work is done. Your slot will get emptied. I didn't get the time to complete my complete animation, so I'm just explaining it as a. So just think about this one. Okay, so again, once the task is complete, it will the executors will again go empty, and it will ask for Spark for the next thing, whatever the next task is. Then again, it will have the task. Then again, it will complete that task, and the slot will get empty. And it can happen in some cases that your half of your executors have completed your task, and half of them have not completed the task. And what issues it can cause, or what problem it can cause, I don't think that is that I can cover in today's session, but that is also one more thing. Okay. So basically, okay, so this is basically about the basic architecture of Spark, how basically Spark job works. So whatever job you have written, you will it will first you'll submit that job to the Spark master daemon. The master daemon will ask cluster manager to give the resources. The cluster manager will give the resource. It will start the master. Then it will start basically driver, and it will start your Spark session. And then it will ask your executors to start. And then whatever the task that driver has, it will assign to the executors. And at the end, they will send the result back to the driver, and then the driver can give them the other task. And in case something is not working fine, let's suppose one of the executors is taking a lot of time to complete and the others have completed that task, so Spark can even assign those tasks to other executors, and whoever completes that task first will get this. Okay. So now, so this is basically Apache Spark. So now the APIs of Spark. So how do you work with Spark? Okay, basically, whenever for any framework or anything you want to connect to, you need to have some sort of application programming interface so that you can communicate with them. Correct. So Spark has it's a basic abstraction. When I see the Spark core is basically three things. Okay, uh, three things, or in categories you can say two things. First is the RDD, and second is the distributed variables. Okay, so distributed variables there are basically two distributed variables, uh, broad, broadcast variable and accumulators, and RDDs is basically your resilient distributed data set. So it's basically giving you interface over your normal parallel processing job. So basically, whatever processing you want to write, let's suppose uh, you want to do something, so that will be there in the RDDs. Okay. Now RDD was the earlier version. There you had the complete control of everything. So if you want to just do a simple group by, let's suppose you want to find a simple aggregate, then that was a huge task because you have to write all the things in the MapReduce concept. Uh, sorry, so sorry, I have not told you what is MapReduce. So uh, so for a distributed framework, so the MapReduce is a concept which was introduced. So basically, whatever task you want to perform, and you want to distribute it among this. So a good example would be, let's suppose you are a class of students, okay, and you want to basically categorize what are the books available in a library, okay. And so in a library, what category books we have, you want to categorize that job. Basically, that is the work you want to do. So how will you do that? Okay, so most probably what will happen, so a student will be assigned a rack which contains a book, or a bookshelf which contains the book, and he can just note the book, and he can come with, okay, this is the name of book, and this is the genre of the book. So it's a science fiction, or technology, or something, or let's suppose since it's a college, so it can be based on the subject as well. So anything can be there. So that stuff will be assigned to one student, will be assigned one basically bookshelf, and there are multiple bookshelf, and you have some bunch of students which will be basically going through one bookshelf at a time. Okay, so basically what you have done is basically you have divided your task into multiple students, and at the end the coordinator or the teacher which is responsible for that, uh, what it will do, it will basically get the results from the students, okay, uh, just get the results, and then they can come up with, okay, so these are the book, for this thing, these are the books, so for max these are the books, for this these are the books. So that can be done at this end. So basically whatever job we had, the huge task of getting to know, okay, so what are the which are the books in what category, so that was divided into multiple people, and then basically you have the result in one sheet, or one notebook, you can say, or one file. Okay. So So the first step of dividing the work among the multiple people, it's called as the map stage. Okay, and second stage of collecting the results and then aggregating that result is called a reduce stage. Okay, so whatever task you want to do in a distributed system can be divided into this MapReduce concept, or it can be mapped in the MapReduce concept. Okay, so that's how the original way of working even with Spark was, because since Spark was made to replace the MapReduce at that time. Okay, so maybe a lot of you might not be getting what I'm saying, uh, but okay, so that's what I can come up at the time. I forgot to add this slide for that MapReduce concept. Okay, so then so these were the RDDs earlier. So now what people were coming, so people are coming in from the different industries and they wanted to work in a different way. So let's suppose uh, most of the data when the Spark was there, it was a structured data. Basically, it was available in some databases. Okay, and they were there for the long time using the database, and they wanted to uh, use the same way that we are using. So basically, they wanted to use the SQL. So how can they use the SQL? Or let's suppose a lot of people were coming from the Python world, so they wanted the data frame like interface, or from the R world, there also you have the data frame concept. So that's where you that's when this thing was introduced. So basically, we call it high level API. Basically, we have the three high level APIs: dataset, data frame, and SQL. Okay. So why are we calling it as a high level APIs? Okay. So basically, whatever code that you're writing in data frame, dataset, or SQL, that is being converted into the RDDs, which is your lower level API, or you can call it as Spark core as well. Okay, so whatever code you write is basically converted into RDDs. Okay, so that's why they are called as high level APIs, and they are abstracting a lot of work that you're doing. So let's suppose earlier you want to do a simple count, so everybody has to write the logic of that count. Okay, so now using the data frame, you can directly use group by count method, and then it will perform a count for you. Okay, so that so a lot of things are abstracted and lot of optimization have been applied. Okay, and how this optimization are applied in the Catalyst framework, I'll explain you in some time. Okay, now you have the high level API. So on the high level APIs, on the top of that, you have the different frameworks like the Spark structure streaming, your Spark ML, uh, your graphs, deep learning. Then you have the ecosystem packages like the Spark NLP, if you're aware of. So Spark NLP is a really good package if you want to work with the NLP. Or let's suppose you want to work with the scientific data, you want to use a Spark or a Spark X-ray. That is there. So there are a lot of frameworks on the top of Spark, which are basically add-on to the Spark. Okay, even the Delta Lake, you can call it. It's sort of an extension of Spark, but not fully, but in some manner, because its basic interaction is using Spark. Okay. Uh, so whatever code you write, okay, so you written your ML code, you have integrated with Keras or TensorFlow, or you had some streaming source, you were getting the data from the streaming source, and you wanted to perform something, and then pass on the result to something. So whatever happens at the end, the code is converted into your bytecode because it is going to run on your JVM. JVM works on the bytecode. That's what it is. So basically, whatever code you're writing in the Spark structured streaming or the advanced your ML jobs or your Spark graph frames or whatever data frame, let's suppose you have written some ETL jobs on Spark, or let's suppose you had some text file and you wanted to do a lot of cleaning on that manually and then want to perform some stuff. Then at the end, the code is converted into the bytecode since it has to run on the JVM. Okay, so let's suppose even if you are writing your code in your Python, so there that code is basically converted into the RDDs at the end, and then it's basically converted into your bytecode only to run. Okay. So if you remember here, I have called we have the Catalyst framework, okay, and we have the Tungsten. I didn't explain what is Catalyst framework and Tungsten. So Catalyst framework is basically a Spark optimizer. You'll most probably you will ask this one. This is the most common interview question, I would say. So those who are preparing for interview, I would say just read about the Spark Catalyst framework in detail, even after what I'm telling you. Okay. And Spark Tungsten is basically its way of storing the data closer to cache. What do I mean by that? I'll explain. Okay. So what is Spark Catalyst framework? Okay. So whatever job you're writing, okay, you had your SQL code, data frame or data set, whatever you've written. Okay. That code. Okay. Sorry. I forgot one of the most basic functionality of Spark. Okay. So Spark is lazily evaluated. What do you mean by lazily evaluated? I'll explain in some time. Okay. But uh, not I'll show you in some time in code. Okay. But basically, whatever job you have, okay, whatever job operations you are performing, they are written in, they are basically written in some DAG. What is DAG? So I'll not go to that. Okay. So basically, whatever operations you are performing, it is basically being written, and until and unless some operation called as action, and operation called as action. Action is basically something when you write something or you are basically collecting the results. So that is called an action. Because suppose you are writing to some data source or some file system, that is the action. Or let's suppose you are collecting some data, or you're basically want to print that data on the console. So that is an action. So until and unless uh, so whatever operations you are writing, it will not be performed until and unless you have some sort of action with you. Okay. So basically you have this Spark SQL, Spark data frame data set. Okay. It basically gives you an unresolved logical plan. So what has to be performed, it is not decided yet. Okay. So then what will happen? It will first perform the action of read. So read is actually also an action. Okay. So whatever you do is basically you will first have the logical plan. So what you want to do, you do Spark framework doesn't know okay, what you want to do. Okay. Then from there, it will look into its catalog. Okay. So does it have something similar to it? It's basically a tree-based structure. And then from the tree, you have the tree searching up algorithm applied, and then from there you get it passes to the analyzer, and then you get a resolved logical plan. So what can be done? So a good example of it is basically, let's suppose you have read a CSV file, and from that CSV file you have basically filtered one column. Okay. And then you are writing to again into a CSV format. Okay. So what Spark will do is instead of reading the complete file in the resolved logical plan, while reading itself, it will filter the rows which are there for that column only. Okay, whatever the filter condition you have written for that column only. Okay. Then from this whatever resolved logical plan you have, then it will again go to the optimizer. Okay. So based on the first read, okay, at the first read, whatever read statement you have, what it does is basically collects the statistics of the file. Okay. So what is the file size, how many partitions it will be there, and based on your job from the logical plan, it comes up with the uh, what will be my cost, okay, to process that job. Okay. Then you will have sorry, I jumped the gun. So basically you will have a resolved logical plan, and then it will go to the optimizer, and then you will have the optimized logical plan. So basically what I told you about this operation of filtering, if you see in this diagram in the resolved logical plan. Okay. So basically you're seeing that there was one block, then it is converted to another block, and then from there it was being joined to the other block on the right hand side, and you are getting the resultant block. Okay. So instead of that, what it did is it just basically combined these two blocks so that work can be done at that point only. I'm just talking really high level right now. I'm not going into detail. It I might sound something wrong, but please bear with me for some time. Okay. Then after this thing, it goes to the physical plan. So physical plan is basically based on what is the size you have, the size of file you are working with. Okay, based on that, it goes to the cost model, and your cost model will give you a best physical plan. Okay, so what is the best way to use it? So a good example of it is basically changing the type of join, uh, that we are not going to cover today, but I can have another session for that. So basically, what sort of join you want to perform, basically changes the type of join. Okay, then from there, it is basically whatever your physical plan is. The generation of physical plan is basically your whatever code you have written is basically converted into an RDD, and now and then it is basically run on your executor. Sorry, on your cluster. Okay, so sorry. So this is basically Spark Catalyst framework. Okay, but now, okay, this was you can say before Spark 3. Okay, now in Spark 3, one more thing was introduced. It is called as the adaptive query engine. So it is basically a feedback loop between your physical plan and your optimized logical plan. So basically, whatever your best physical plan is changed based on the statistics at each and every stage. Okay, what do you mean by stage? So basically, if you see in your logical plan, so this was my first stage. I had two different blocks. Joining these two blocks, I got to another block, and then from this block, I'm getting to another block. So whenever you go from one block to another block, you are basically going from one stage to another stage. Okay, so at the end of every stage, okay, at the end of every stage, what it will do, it will again go through the cost model and again try to choose the best physical plan going ahead. Okay, that is called as the adaptive uh, AQE is called as, I exactly don't recall the actual name. So there is a Spark property called as enable Spark adaptive query plan. Okay, so what you can do is basically, if you turn that off, you go to the before Spark 3. Okay, and if you are turned on, basically you are in the above Spark 3 world. Apart from the some basic changes of APIs. Okay, and let's suppose if you want to go back to the Spark 1.x, then you basically write your code in RDD. Okay, so basically the this thing which we had. Sorry. Okay. So basically, if you see this thing, so if you see the lower layer, the distributed variable low level APIs RDD, this was basically your world in the Spark 1.x. There was Spark SQL, but it was at very nascent stage, and there was a streaming API at that time, which is there till now, but that is different. Okay, but if you want to go back to the Spark 1.x, then basically if you're using RDDs, you're basically going to Spark 1.x. And if you are using the high level APIs like the data frame dataset or Spark SQL, you're basically in Spark 2.x. And when you turn on your adaptive query engine, then you are in the Spark 3.3x. Okay, that's what I'll classify between these three. Okay, so some basic features of Spark. So this is just some basic stuff. So basically, it's a distributed cluster computing, a single master and fault tolerant, distributed data structures, lazily related. All this. Oh, I think okay. I think the sequence went wrong. Okay, no issues. Whatever it does, it tries to fit all the data in memory. It is scalable, and then there is a fault tolerant. So when a node is since you're working in the community hardware, so node might fail at any point of time. And then also your system should able to continue. Basically, I'll provide you this thing. So basically, not much. Okay. So now this is really important. Okay. So this is not made by me. So I have taken it from the Heather Miller's presentation sometime back for this Spark. Okay. So I've basically taken the screenshot of that video. Okay. So basically, this latency number. So it is basically called as a latency number. Every programmer should know. It's basically the thing. So if you are in the RAM of L1 cache or L2 cache or mutex or main memory of your this thing CPU, so that is closer to CPU since it is inside the die. Okay, so that is your fastest memory or the fastest storage. Then let's suppose you come to the memory, actual memory, which is on your motherboard. Not it is directly connected to your CPU, but it is uh, it is it is going to the copper wire. Okay, then you have your files, okay, which are written in your disk, and then you have your network. Okay, so let's suppose if you're reading some file on your disk. Okay, if you're reading some file on your disk. Okay, so what will happen is that file needs to be first serialized. That means it has to be converted into the uh, binary format. For that, it has to be copied into memory. Then it will be passed through the cache, and then it goes into your CPU. Okay, so that's how your stuff is. So when you're reading the file, and when you're going to the network, so network is almost the same thing. First, it has to come into your memory, then it will go into cache, then into your CPU for processing, and then when it is completed, then at that time it will be sent to a network. Then from the wire, if it's fiber or your normal copper wire, based on whatever bandwidth you have on your network connection, it will go to the other place, and then it can be processed again. So in that scenario, also there is also operation of first it has to be serialized and then has to be deserialized before sending, because it is coming out of memory into the disk so that it can be sent to the outer world. So this is a really important stuff. So why I'm talking about this is basically the Spark was designed keeping this into its mind. Okay, so whatever operations I'm performing, okay, if they are in memory or in cache, so they are faster. Okay, so if you remember the five basic things which was kept in mind uh, for uh, for Spark to be successful while making Spark was you need to have the speed. Okay. So how do you have the speed? You will have the speed when your data lies in the first quadrant, where it is called where it's marked as memory. Okay. So basically, you want to have your data in memory at all the times which you want to process. If that is not possible, then might be we can have it in the off heap memory. Okay, what is off heap memory? I'll come to that. Okay, then then if that is not possible, then on disk. And in the worst case scenario, it should be stored in some remote place where everybody can access it in worst case. But right now, everybody is using that thing because of the you can say the cost optimization. So basically, whatever data that you have, that is stored in your cloud storage. Okay, but the thing is, since your computer is also running in cloud, so there is you can say some amount of locality to it rather than running on your laptop. Let's suppose if you try to run uh, a simple job with 20 MB of CSV file on your laptop, Spark job, and your file is stored in S3, then you come to know what I'm talking about. Okay, so uh, that is it. So basically, what Spark tried to do is it tried to keep everything in memory, and if it is not possible, then off heap, and then if it is not possible off heap, then it should be on disk. And in the worst case scenario, it can lie into sub network storage.
Sure. So I would like to add one point which just now it just shows in the showed in the end, that in where the memory section is being presented in a well thing. That is very important to understand, because it's an in-memory engine, Spark, and all the algorithms has been designed to get optimization on the memory side, not on the hard disk side. So when we think about this ecosystem of hard disk is good enough, SSDs are fast. As I said initially, none of the thing happens on hard disk. You need to put the instruction set of whatever the thing you are doing in memory. Then there will be page table, virtual memory, virtual address, a lot of things will happen, but your CPU will only work on the memory, not on the hard disk. So you need to pull that thing. And if you consider that your data sit in S3 or any Google or any cloud storage, and you say that Google storage is, for example, in US and you are sitting in India, then you need to understand that data need to transport from that US server to your Indian server. So the storage is sitting in some hard disk, spinning disk in USA, and over the network it will come and come back to your particular system of memory, and then all internal CPU things will happen, the instruction will process. So Spark will do all the magic. So that's why all these things delays. If you remember this ecosystem, you will realize that when you will code in Spark, you will understand what does it mean by keeping compute and storage closer. It means if you are in cloud and you can create a compute server in US location, the same thing will be processed faster. But if the thing is vice versa, that your storage in US server but your compute is in Indian server, things will be slower. So that's the intention of understanding how all these distributed systems cleverly use the you can say speed. Like we realize everything is speed of light, but it is not. And this, there is the, even the data transfer is a, even the millisecond is a huge latency if you consider in the CPU and computer world. And that's why this that particular diagram what Hitesh showed is so important to understand. Meanwhile, we have some question. Uh, how long future technology asks us how long Apache Spark. Oh, it I think if I'm not wrong, it is this. It is widely known. At least when I started using it in 2000, at least in 14, it was very widely known. Yeah, 2016 as, yeah, 2016 as well. 2006 was already popular, so I don't know the year, but 2014-15 it already came up and it was pretty massively used. And there was one question earlier where somebody said. When an application is accepted by Yarn, that means it has enough resources required for app. But sometimes it is stuck middle of execution due to resource constraint. What are resources it has to have? Uh, yeah, go ahead, Hitesh.
Yeah. So it's basically like, okay, so let's suppose you started your cluster, okay, your cluster had enough compute when you started, okay, and you, let's suppose you needed 2 cores and 4 gigs of memory for your driver, and then it needed some number of cores and memory for your executor, and your yarn basically assigned that resource to it, okay. So now your job is started, okay. So as you know, in most of the cases your jobs are basically your dynamic allocation is on, okay, and you're sharing resource with the other jobs, okay. So at the time you started, okay, it was working fine, and in some cases people basically what you call over provision, and they do not keep any memory for OS to run. That is also some case, okay. So what will happen when your job was running, it was working fine, everything was working fine, but when some other job comes into the picture, it is basically impacting you. It's basically your noisy neighbor in your cluster, which is impacting you. In most cases it should not interrupt, but what happens, let's suppose when your job or when your executor is doing some stuff and it crosses your limits for, so basically if you remember in the architecture, if I say so there was a master, my driver, and then I had the multiple executors, correct. So my executors are communicating to my master, So what will happen when your executor is not communicating your results back to your Spark? Okay? So at that time, your job gets stuck. Basically, that resource is taken. Okay, and since that executor is not communicating with the Spark, uh, it doesn't know what is the state of it. So normally, what it does, it basically waits for some more time. Okay, and if it is not there, then it asks your cluster manager to kill that executor. So in what happens in some cases, the cluster manager has given that command to kill that thing, but it is not killed. That process is not killed. Okay. So to the cluster manager, that resource is available. Okay, but it is actually not available because your JVM process is still running there. And when you submit another job, so according to cluster manager, that resource was available and it assigned that resource, and basically this creates this problem. So your jobs will get stuck because it was supposed to get that resource, but it is not getting the resource.
Now I think, considering the time, we can directly jump into the questions and we started further. I think we have one question which touch one part, that how long Spark will survive in bottom line, and like it is the coolest technology. And we have a question on latest use cases of Apache Spark in data engineering in current generation or in upcoming 3-4 years.
So the latest usage, that is really hard question. I would say it's not a simple question to answer. So the latest use case is basically whatever latest use case you have in your data engineering domain. So be it IoT or anything. So it can be anything. Okay. Uh, because it's a general processing engine. So whatever you have a use case, and if it has a data source available, then you can basically use Spark to solve that thing. If not, then you can write your own data sources. That is a hard way to do it, but that can also be done. So the basically question is, what is the latest use case? Is basically what is the latest problem you're facing, and and does it require a scale? So the main point of using Spark is, do you require a scale? Okay, so I'll give you an example. I've seen a project which had the amount of data it was processing was around 500 MB a day, and they were using Spark on it, and they were wasting a lot of time on it, and they had the uh, SDP platform and everything taken into project. I was saying, so I asked the guy, why are you using this thing since you have just 500 MB of daily data? So just for the name of Spark, why are you adding additional complexity of handling a cluster and optimizing your and writing your Spark job, and getting a Spark resource is really expensive in the market. If anyone is hiring, I would say it's at least in India, it's first of all, you do not find a good resources. Uh, Believe me, I have taken at least 100 interviews last year, and at most 5 or 6 people, I would say, they had the experience which they had written in the CV. So that is the thing. So basically, whatever use case you have, so is it scalable? So does it require the scale? So that is the thing, and uh, is it coming from the known data sources? That is the latest use case you have a Spark. Apart from this, you can say managing your data lake. That is the most common thing right now.
Any other opinion on using Spark? Because I have a very different opinion, which I would like to go in the end. But is there any other opinion who wants to share what will be the latest use cases of Apache Spark?
Mostly on migration cases, for large data migrations, we'll be using Spark for converting one format to other format.
That's a good point, actually. It's actually a nice point.
Yeah.
So when it comes to any other point before I vouch in, okay. So even if it is there, just interrupt me. In case of what both of you said, I totally agree. But when it comes to the Spark, first you need to ask a question that if you have a structured data already, and the data is structured. It means it is in Parquet, it is in Avro, it is in CSV, and having a databases which is like querying the data and directly writing processing is easier, and your team is very much not a very coding ninjas, or you want to write less code and you want to go with the approach of SQL, then it is absolutely not necessary to use Spark. The scalability point of Spark is no more only stick with Spark. There are many distributed databases which just does this thing for you. And if why those are easy, because Spark is complex. Managing Spark is complex, and that I always say that managing Spark is complex and tuning Spark is a headache. Like, you can imagine that, yeah, I can load a data frame, it is a finest thing, I will turn on adaptive query engine which is automatically scale, and then I will use this thing called dynamic allocation which will automatically scale things. I would say those are not the finest, those are not perfect. So though most of them over provision and over complicate, and lot of time your cluster uses is not optimized, so you burn up more. But when it comes to database, you will just get a setup, you will put a connector, and that's it, you go ahead. So if you have engineering resources and if you just don't load data and you do very complicated transformation, which really has a value of making reusable using code, then Spark is brilliant. But if your queries are denormalized and you can create a proper solid data model behind it, and you are just doing query transformations by selecting this query, putting some window function on them, and then write it back to another databases, then you don't need Spark. So in the latest use cases with that question, I will say whenever you have very complicated setup where you have many kind of different files, too many layers, too many connection, and the engineering effort is high, then Spark is brilliant, or else databases can solve the problem. Now there is another question, which is how to write an efficient Apache Spark job.
Okay, so I would say we can have another session. Actually, I was lot of hurry to make this whatever stuff I've made right now. So I'm not there with my demo completely. But if I had demo, so I could have tell that. So we can have another session on that. So writing you can say efficient Spark code and avoiding using the UDF. So that was one topic I had discussed earlier with Abhishek that I was going to present. Actually, I was supposed to present that today, but I didn't get time for that. So then he suggested getting started with the introduction of Spark. But that also I don't think I have completed the introduction to Spark. Spark is such a big thing. I don't think I had enough time to complete that today. But we can have another session. Maybe not another. Maybe we can have 4-5 sessions.
That's a good.
Yeah, maybe we can. Yeah, maybe we can have 4-5 sessions.
Yeah, it won't be one
So,
session.
yeah.
So I will just say when it comes to the writing efficient Apache Spark job, the only thing you can do efficient is on a very basic level, don't write UDFs. I use the word don't. There is almost always there is some functions in Spark which can do the job, and if it can't, don't go with map. Try for map partitions. Try to understand vectorization as a concept, that if you try to run functions over a chunk of data, it is always faster than doing one by one. So if you go with the Spark and if you find something's very easy, don't believe it. Go to the doc and read what other functions you can use to optimize it. Then when it comes to data, and we have a discussion here as well, you don't need RDD technically, at least for starting. RDD access and understanding in depth of RDDs comes in a very rare events where you are actually solving some custom problems, which is not with most of the cases. So I would say data frame and data sets are brilliant in those levels. You can use SQL if you still need to use Spark, but you are not comfortable going in Python or programming. It is absolutely fine. There is nothing wrong in that. You can definitely use SQL, Spark SQL to do everything, and there is no performance hurt. And another efficiency on the Spark side come is that don't do too many reads and writes, and don't overdo complicated transformation. So both are balanced. It means if you have if you are reading a data and you are doing 10 different transformations, reading it, transforming it, then again transforming it, then again transforming it, my suggestion, write it. My suggestion is just create a break in the stage, write the data, then read it back. It is going to be faster. But if you are doing too many times read, write, read, write, read, write, it is expensive. And the final thing is size of files. Small files is a killer for any distributed system, and for Spark it is same. If you are writing too many small files, or if you are reading too many small files, you are out of luck. If you are working with text files which cannot be split when reading by Spark, you are out of luck. So these are basics. When you without a session, I can say that these are some things which you can do to write a efficient Spark job. I would like to close off the session for now. If Because it's we already crossed the time as usual. Thank you very much. Thank you for your time and patience. If you have any other question, kindly reach out to us in Telegram, and we will go ahead with the other question from there. Okay.